So let's just see how we can delete a node at a particular position in the circular doubly linked list. So here is the algorithm to delete node at a given position. So first of all, we have to check if the list is empty or not. That means if the head is pointing to null, then the list is empty. So in that case, we're just gonna simply return. Otherwise, we have to traverse the list. So we have to use the temporary pointer, which will initially point to the head. Then we're gonna use one loop to traverse to that particular position where we wanted to delete the node. Now suppose in a case the node is the only node in the list, our list has only one node. So in that case, we have to delete this node. Simply we're gonna free that node. So we're gonna free that node and we're gonna return null. Otherwise, we have to update the link. So suppose we wanted to delete this node, then we have to update the link of the previous and the next node. That means the previous node's next pointers should be updated to point to this node, and the next node's previous pointer should be updated to point to this node. So we are basically isolating the node to be deleted. And lastly, before freeing this node, we have to check the node that we are deleting, if that is head node or not. If that is the head node, that means we are deleting the first node. In that case, we have to shift our head pointer to the next node, and then we can free the memory of that pointer. Otherwise, you don't have to modify the head. We can just simply free the memory of the temporary pointer and we can return the new head. So that is the simple algorithm to delete a node at a particular position. So currently we have 3 nodes in the list. Now here we can write the function to delete node at a particular position. So we're gonna call the function delete at position. So the function will take a head pointer, and also we're gonna pass the position where we wanted to delete the node. So first of all, we have to check if the list is empty or not. So if the head is pointing to null, that means the list is empty. So in that case, we can just simply print list is empty and we can return null. Otherwise, if we have multiple nodes in the list, in that case we need to use one temporary pointer which will initially point to the head. So let's just create one temporary pointer which will initially point to the head, and now we have to traverse to that particular position. So we need one counter to reach that particular position. So we're gonna use the while loop. So while the counter value is less than the position, we're going to continue the loop, and in every iteration we're going to shift the temporary pointer to the next node, and also we're gonna increase the counter value. So that means in each iteration we're just shifting the temporary pointer to the next node. Now after shifting the temporary pointer, if we found out that the temporary pointer is pointing to the head node, so that means the temporary pointer is back to the head node after circling the whole linked list. So in that case, we can just return, because here the position is invalid. So here we can print position invalid, and then we can just return the old head without doing any kind of modification. Now if we have the valid position, then after the end of the loop, our temporary pointer will reach to that particular position. Now here we're gonna check if the temporary pointer's next node is the temporary pointer itself, and also the temporary pointer's previous node is also the temporary pointer. So that suggests we have only one node in the list. So in that case, we have to free the temporary node and we're just gonna return null. So that is in case when we have only one node in the list. Otherwise, suppose we have multiple nodes, so in that case we have to update the links of the previous and the next node. So here we're gonna update the links of the nodes. So here we wanted to delete the node 200, so we have to update the links of the node 100 and the node 300. That means this previous node's next pointer should be updated and the next pointer should point to the node 300. Similarly, the next node's previous pointer should be updated. So this is the next node and its previous pointer should be updated and it should point to this node 100. And this way we can successfully isolate the node to delete. So here we're gonna update the previous node's next pointer and it should point to the next node. Similarly, we have to update the next node's previous pointer and it should point to the previous node. Now before deallocating the memory of that node, we have to perform a simple check. We're gonna check if the node that we are trying to delete, if that is the head node or not. If that is the head node, then we're gonna shift the head to the next node. So here we're basically checking if the node is head or not. And now we can free the memory of the temporary node, and then we can return the head after the modification. So that means our node is successfully deleted from the list. So currently in the list we have 3 nodes. Now we're gonna call the function delete at position. First of all, we're gonna pass the head pointer and the position. So first of all, let's just delete the first node. Now we can print the list again. So here the first node 100 is deleted from the list. Similarly, we can delete the third node of the list. So here you can see the third node 300 is removed from the list. So this way we can delete any node from a particular position in the circular doubly linked list. So hope you understand the concept. See you in the next one. Take care.